Hello everybody, my name's Stephen Liedig. I'm a Specialist Solutions Architect with the AWS Serverless team here in Australia and New Zealand. And today we're going to give you a presentation around what's new with serverless. So in this webinar, you'll learn about how to drive your business's agility through building cloud-native modern applications with the latest updates from AWS Serverless, including EventBridge, AWS Step Functions, Express Workflows, HTTP APIs for API Gateway, and provision concurrency for AWS Lambda. We'll also look at a whole range of key new releases that show you how we're investing in our services to continue to improve core functionality, enable new application development patterns, and empower serverless developers and operators. So there's a lot to cover, so let's get started. So we're in the middle of a paradigm shift. Cloud providers are automating and abstracting away as much as possible, which is really in direct support of what business leaders want us to achieve, to build better products and to win more customers. In IT, our ability to do that at a rapid pace has improved significantly with infrastructure as code, CI/CD pipelines with automated security and compliance, and of course serverless. So as leaders, we must find a way to emerge from our current state, skill sets and organizational structures in support of those business objectives. And they're largely achieved through these five key characteristics that drive companies' need for modernization. Customer obsession, with the wanting to be able to create frictionless and immersive and consistent experiences across a number of different channels. Being organized for value and showing leadership alignment, funding and structure around discrete business outcomes. Testing and learning, so we're as a learning organization are focused around experimentation by creating and testing hypotheses. And having technology at the core. So having senior leaders understand technology deeply and use that to inform their business strategy. Although this does not necessarily means that you become a technology company. And finally, data, which is really a core asset for many organizations and used to help you make decisions and making that data much more accessible. And serverless plays a key role in delivering this transformation. It allows companies like Capital One to release new features in weeks by enabling developers at a global level. The Guardian, who've spent a lot of time and money investing in testing and learning how to fail quickly, and that's given their employees new opportunities to learn and help their retention periods as they move towards more agile practices. And then there's of course McDonald's who've adopted serverless to help deliver their home delivery services in a very short space of time. It's now scaling up to over 1 million orders an hour. And of course FINRA, who monitor financial markets in the US, and are basically doing 1,000x more on analysis on market events that has reduced their analysis time from minutes to seconds. So what are our serverless tenets? So by now I hope that we all understand that serverless doesn't mean that there are no servers. It just means that there are servers that you don't need to care about. So we see serverless through a wide angle lens that includes any AWS service that frees DevOps teams from capacity planning and infrastructure management and allows applications to scale without explicitly increasing a hardware footprint. And it's also secure and resilient without any additional extra effort. And we often describe this as getting the benefits of $1 billion IT budget, even though you're only paying for the resources that you're using. And you can sort of see that how serverless is really aligned with this concept of a shared responsibility. And this spectrum really shows how, as we move to the right, things are moving much more to our managed environment, where if we do need finer control over the infrastructure that we manage, we move over to the left. And this shared responsibility model implies that there are parts of the system that AWS is responsible for, and that there are parts of the system that you as customers must take responsibility for. And in many cases, we provide the tools, and there's a rich ecosystem of open source and commercial products that make it easier for you to own your side of the responsibility box. But as you move to the right, that sort of starts to go away. And as we look at this example of how we can apply operational responsibility to compute, let's take a look. I mean, the customer is managing a fair bit here. Everything at an EC2 and even at a container level, we're still managing a lot around application code, scaling and security configurations, and applying network configurations and management tasks to help provision and manage the scaling and patching of servers. And as we move up the band, the customer's responsibility starts to lessen, and we're taking on more ownership around all of the things that don't provide you a competitive advantage, things and help you manage things like scaling and provisioning and patching of servers, as well as making sure that those services are highly available, so you can focus on the things that really matter to your organization, which is really the application code and where you're sticking a lot of your IP and the investment for your applications. So how are we focusing our efforts? Now, before we get into this, let me ask you a quick question. How many new features do you think we launched in 2019 across Lambda, API Gateway, and Step Functions? I'll give you just a couple of seconds to think about it and take a guess. The answer is 36. We spread that, and in addition to that, we created and launched an entirely new service called Amazon EventBridge. Now, I want to spend a little bit of time talking about this, just for those of you who've not come across it yet. So last year we announced the launch of Amazon EventBridge, which is a new event bus service that makes it easier for you to ingest and process data across AWS and SaaS applications. Now, EventBridge removes the friction of writing point-to-point integrations by letting you easily access changes in data that occur in both AWS and SaaS applications via highly scalable and a centralized stream of events. Now, with EventBridge, you get a simple programming model where event publishers are decoupled from event subscribers, allowing you to build loosely coupled, independently scaled, and highly reusable event-driven applications. And it's fully managed, so it handles everything from event ingestion and delivery to security and authorization, as well as error handling, making it easier for you to build scalable event-driven applications. And because EventBridge is serverless, there's no infrastructure to manage, and you only pay for the events that you consume. So let's take a look at how EventBridge works. So it all starts with an event source. Now, these can be either an AWS service or custom events or SaaS applications that you provide. Now, with the AWS services, there are now over 115 services that you can use to provide integrations through EventBridge. Everything from augmented UI through to EC2, EKS, our security suite of services, and even EventBridge itself. And then, of course, you've got event sources that you define and include in custom applications that you write, as well as SaaS applications. And there are now over 24 EventBridge SaaS integrations that you can take advantage of and use to use the events that are emitted in those service providers and start integrating them in applications that you build and own inside your own AWS account without having to do a huge amount of work. Now, here's an example of a couple of SaaS integrations at an ANZ level. Atlassian's Ops Genie and also Whisper's messaging platform are part of the as part of the suite of service providers that provide this capability. So when you create a SaaS application integration, there's a special resource called the Partner Event Source, and that provides a logical connection between the partner's system and your AWS account, with the need for provisioning and without the need for you to provision or manage cross-account IAM roles or credentials. Now, at the core of EventBridge are event buses. If you're familiar with CloudWatch Event's default event bus, this is exactly the same thing, except you can create your own custom event buses as well as those buses dedicated to ingesting partner events. And then once you have an event bus, you can associate rules with it. And these rules allow you to match against values in the metadata and the payloads of the events ingested to determine where the events should get routed and integrated into. And that can be any one of 19 integratable targets. And you can associate multiple targets with each rule in order to send events that match the appropriate destination. Now, targets allow you to do things like invoke Lambda functions, put a record on a Kinesis data stream or a fire hose, or start the execution of a step function workflow, or start a task using ECS or Fargate. Now, we also have a feature that is part of EventBridge called the Schema Registry. And that is now globally available, generally available across all of the major regions in AWS. Now, the Schema Registry is there to be able to describe the structure or effectively the schema of an event. So makes it easy for developers to find and discover events that would typically be discovered manually through documentation or other means of being able to describe events. Start this again. Take two. So a core feature of EventBridge is the Schema Registry, which is now generally available. And to react to events in your applications, developers need to know the event structure or the schema. The process of finding events in their schema is typically manual. Developers have to look through documentation or find the event's author. Now, the EventBridge Schema Registry makes accessing schemas easily by centralizing the storage of schemas generated by all of the event sources in any developer in your organization can access them. And you can also download code bindings which allow you to represent the events as an object inside your code and take advantage of IDE integration features such as validation and autocomplete. And you can download code bindings for programming languages such as Java, Python, or TypeScript and use this code in your IDE via AWS Toolkit for IntelliJ and Visual Studio Code, or you can still use the AWS console. When the Schema Registry discovers the Schema Registry discovery feature is when that's turned on, all of the events sent to an event bus are automatically added to the registry, so there's no need for you to create those schemas manually. Because we've recognized that defining schemas can be challenging. So through auto discovery, you've got the ability to store the discovered schemas in a directory and create your own registry off the back of the schemas that get generated for you. So you can then align them to applications and categorize them in any way that you need, that makes sense for your organization and your applications. And you can start sharing those registry across your organizations. So how else are we investing in our work? Well, this boils down to about effectively three categories. First of all, service fundamentals. Now we continue to push for improvements across across the board in availability, latency, scale, and security. And we know that you enjoy the ease of serverless, but not necessarily things like cold start latency. And here we're making some key investments. We continue to work towards optimizations to reduce the steady state latency and also drive overall product improvements to address cold starts. And we're also enabling new application patterns, and we continue to invest in supporting new event sources, new control flows for orchestrating workflows, and new patterns like asynchronous callbacks. And of course, we're continuing to support serverless developers and operators as we work towards providing improvements in the AWS toolchain, and also the broader ecosystem where where developers are working. And we want to make it easy for customers to bridge what they have while adopting serverless. So let's take a look at some of the ways that we've been listening to customers and the features that we've launched to support that. So we've been hearing things like, we need better performance and more control over the behavior of the black box. Now, one of the ways that, and this is very much aligned to EventBridge, that we can help extend the configurability of an event-driven architecture is through a new service feature that we released last year called AWS Lambda Destinations. And this feature effectively allows you to send the result of an asynchronous invocation to one of four destinations, it either being a Lambda function, an Amazon EventBridge event bus, SQS, or an SNS topic. And you can configure that for either a success or on failure, simply by providing the ARN number of the services that you want to route to. Now, one of the nice features around dealing with this is that you can have this whole concept of event processing continuity, and also the on failure configuration provides some additional benefits by providing context information around what caused the error, so you can then handle that and inspect that much more easily than you otherwise would be able to. And then we've released a new feature for Amazon Gateway in HTTP APIs. And this is a new capability for API Gateway that allows you to create a HTTP endpoint. That allows you to create HTTP endpoints and do so at a much cheaper and with much greater performance compared to the REST APIs that API Gateway currently supports. And it also makes it much simpler for us to be able to support service features like security from a JWT authorization perspective, providing native support for OpenID Connect authorization and OAuth 2 authorization scopes. And we've made it simpler to deal with stages and routes by providing the capability to specify default stages and routes, so you don't have to go through the process of explicitly defining a stage for your APIs, and then enabling auto deployment to help facilitate the publishing of those APIs as well, and creating a fully customizable calls experience directly for those APIs, and making that experience also much simpler. The other thing that's currently in preview is this whole idea of is a new service feature called Amazon RDS Proxy. Now, this is a fully managed, highly available database proxy for Amazon's relational database service, RDS, that makes applications more scalable and more resilient to database failures, and much more secure. So some of the core benefits of RDS Proxy are things like managing database connection pools and shared database connections for improved application scaling. So here the proxy instance maintains a pool of established connections to your RDS database instances and reduces the stress on the database and database compute and memory resources that typically occur when new connections are established. And also allows you to increase the application availability, manage application data security much more easily, and is fully compatible at this point with services like Amazon Aurora MySQL, MySQL, and Aurora PostgreSQL, as well as RDS Postgres SQL. And there'll be more engines coming soon. So we've also been hearing from customers we need better tools and information to observe our applications. And we've made some headway in the way that we can achieve that by making it easier to generate and monitor metrics and state, by supporting percentiles within AWS CloudWatch metrics for Lambda functions, as well as creating workflow execution events for AWS Step Functions, and Amazon API Gateway logs being able to now being sent to Kinesis data firehose. Well, we've also launched through CloudWatch a new library called Embedded Metrics Format. Now, this is ideal for generating custom metrics across a number of different compute environments, but effectively it's easily generate custom metrics for Lambda functions without requiring custom batch code or blocking network requests or relying on third-party software. But using the embedded metric formats, you'll be able to visualize and alarm on custom metrics, but also retain the original detailed and highly cardinal context, which is queryable through CloudWatch logs insights. For example, the library automatically injects the environment metadata, such as those emitted by a Lambda function, version, and other context information into the structured log data, which makes it super useful to start querying and getting insights into the execution environment that for those logs. And then now 2 open source libraries available, which I've created some links to there. So now we've got example implementations of how you can apply that with Node and also Python. So let's take a look at some of the new application development patterns that we've been working towards. And customers are telling us we want to use serverless for high throughput applications, but we're concerned about scalability and cost. Well, some of the major launches that over the last few months have made it easier and cheaper for customers to build high throughput services. The first one is Lambda support for provision concurrency. Then we've also announced last year reInvent Step Functions Express workflows, and also more recently savings plans for Lambda. Let's take a look at some of these. So provision concurrency primarily addresses 2 concerns for AWS Lambda customers. First, it enables fast scaling by allowing customers to scale up to the entire provision amount of concurrency at once, going around the default burst limits for the respective regions. And second, it eliminates cold start by pre-initializing sandboxes to support applications that have a strict latency requirement. And the use cases where we see here is where the applications have a strict latency requirement are typically those where a direct interaction with end users, such as mobile or web applications, is required, or there are strict regulatory requirements. High velocity traffic also allows you to serve content such as those served through content ads during a live stream, or mobile applications such as games or marketing blitzes or flash sales are good use cases for configuring provision concurrency. Now, through the integration with application autoscaling, you can schedule the concurrency provisioning. Now, because Lambda initializes sandbox if it was under a normal cold start, as long as your code preloads everything it needs to during the cold start, without lazy loading components during the handler's execution, the invocations of a provisioned sandbox will always execute as warm. So provision concurrency scales up using the same rules as the default Lambda scales. So for this reason, it's important to give Lambda a little bit of time before scaling up to the burst traffic requirement. And if the traffic exceeds the provision concurrency, it doesn't just stop, it's handled by an on-demand Lambda that adheres to the same default Lambda limits and behaviors. Now, Express workflows are a new AWS Step Function workflow type that cost-effectively orchestrates AWS compute, database, and messaging services. Express workflows automatically start in response to events such as HTTP requests via API Gateway, Lambda, IoT rules engines, and over 100 other AWS services and SaaS events from Amazon, and things like SaaS events from Amazon EventBridge. And Express workflows can support event rates greater than 100,000 requests per second, making them suitable for event processing workloads. And at $1 per million requests and extremely low per gigabyte second rates, the price of Express workflows enables cost-effective processing even at tremendous scale. And here's an example of some of the core differences. So a standard Step Functions has a much longer maximum duration for each state execution. Express is really limited to 5 minutes. It also has much greater start execution and state transition rates as opposed to a standard workflow. And to achieve this, it only supports at least once workflow step execution. Where we're not persisting state durably, you would have to then restart the executions in order to facilitate that to facilitate the execution of that workflow. And all of the events are sent to the execution. History for those events are sent to CloudWatch logs, where Step Functions standard has all of their step functions stored within the tool within the execution history of that of the state machine, which is really useful for visualizing and debugging in the console. Now, both types of step functions support service integrations. But what Express workflows don't support are the things like the synchronous callbacks and wait for callback patterns that are supported by standard executions. So how are we making it cheaper for our customers to build high throughput services? Well, savings plans are a new pricing model that offers significant savings on EC2, Fargate, and now Lambda. Customers simply have to commit to a consistent amount of usage, say $10 an hour, over 1 or 3 years. In exchange, you'll receive a lower price for that usage. Savings plans offer a significant savings, just like reserved instances, but with greater flexibility. So how does it work? So every type of compute usage that has an on-demand rate and a savings plan's price. So if a customer commits to $10 an hour for compute usage, then they'll get a savings plan price for all of the usage up to $10. And any usage beyond the commitment will be charged at regular on-demand rates. So why would I use savings plans? Well, first, they're super easy to use. Customers no longer have to make commitments to specific instance configurations and can easily save money by committing to a dollar spend. And secondly, they provide significant savings, anywhere up to 72% every on-demand pricing, just like reserved instances. And finally, they provide a ton of flexibility. With savings plans, all you have to do is make a simple commitment and onto a spend per hour basis, and you'll save money on your usage automatically, even though as the usage changes from one region to another, or from instance type to another, or even if you move from EC2 to Fargate and from Fargate to Lambda, all without having to perform exchanges or modifications. So customers are also telling us we want more service integrations and event sources to allow us to build fully serverless applications without having to work on additional glue. Now here we've launched features that enable automatic integration with new AWS services and event sources. The first one is AWS support for SQS FIFO queues. We've also launched additional service integrations for AWS Step Functions with Elastic MapReduce and also SageMaker, and introduced new states for AWS Step Functions, namely the map and nested workflows, two of which have been in high demand for quite some time. SQS FIFO, or first in, first out, preserves the exact order in which messages are sent and received, and support message groups that allow multiple ordered message groups within a single queue. Now, Lambda polls the queue and invokes your function synchronously, and an event that contains queued messages. Now, Lambda reads messages in batches and then invokes your functions once per each batch. So for FIFO queues, the records contain when your function successfully completes that batch, Lambda deletes the messages from the queue. Now for FIFO queues, records contain additional attributes that are related to the deduplication and sequencing. And so depending on the size of the batch will determine the amount of concurrency by which the Lambda will pull the messages off the queue. And this helps guarantee the order and ensure deduplication of messages as they're being processed. Now the map state can be used to run a set of steps for each element of an input array. Now we've had the parallel state for quite some time, but this executes multiple branches of a step using the same input for a fixed number of branches defined in the state machine. A map state, on the other hand, will execute the same steps for multiple entries in an array that is part of the state input. And you can configure an upper bound on how many concurrent sub workflows map executes by adding the maximum concurrency field. Now this default is 0, which places no limit on the parallelism and iterations that are invoked as concurrently as possible. But if you have, say, a max concurrency value of 1, this has the effect of invoking the iterator one element at a time. So you've got some control over the order in the appearance in the input state, and how you start an iteration and allows you to start an iteration until the previous iteration has completed execution. So there's a lot more control around the parallelism, the parallel execution, and also how you're iterating over those arrays. And this allows you to optimize for performance and efficiently process data for application workflows such as data processing or task automation processes. Another major another major step function release was nested workflows, which allows you to orchestrate more complex processes by composing more modular, reusable workflows. So common workflow processes are often repeated in multiple places. Large workflow executions are also harder to troubleshoot when things go wrong. So by nesting your step function workflows, you can build larger, more complex workflows out of smaller, simpler workflows. And when your workflows have recurring processes such as human review and approvals or resource provisioning and accounts, you can create a library of these modular, reusable building blocks for faster development. Speaking of development, how are we empowering the serverless developer and operators? Well, we're hearing from customers most regularly around the native support for newer runtime versions, and this is one of those ongoing tasks that we perform on behalf of our customers. And we've recently updated our runtime support for Node.js version 12, Java 11, and Python 3.8, and most recently support for the .NET Core 3.1 runtime. We also need to test our applications locally before spending money on cloud resources. Now, this is an area where we're continuing to make improvements in frameworks like the serverless application model and the toolkit that supports it, and integrations with IDEs and platforms through the Visual Studio Code toolkit and IntelliJ suite of IDEs. I'm going to cover two examples of how we've applied that through the AWS Step Functions support, through Visual Studio Toolkit, and also the improved deployment process that we've rolled out over the last while for the serverless application model command line interface. Now, here's an example of when you've installed the Visual Studio toolkit as an extension, you get a number of different functionality that integrates directly into your account. And one of those is the ability to support step functions, as well as the ability to visualize and work with the schema registry for EventBridge. Now, the step function support allows you now to visualize the state machine that you're developing directly in the IDE, which minimizes the need for you to jump back and forth to the console to see how your workflow is being visually represented. And we've also added additional support to help with things like validation of the state machine. So you spend less time figuring out what you've done wrong with your with your workflow definition, and can actually address errors straight away. And this is a huge productivity gain. The serverless application model and the SAM CLI have also gone through some major enhancements lately. And that manifests itself around things like guided project initialization, which provides developers a walk-through, step-by-step way for you to be able to create new serverless applications and Lambda functions. We've also done a lot of work around the guided deployments and making sure deployments are simpler by encapsulating the way that your application code is packaged, and also providing you with ways to simplify the way you deploy applications by allowing you to store deployment configurations locally, so you don't have to re-add it you don't have to make sure you add it for every deployment. And we've also integrated the new change set summary and stack output to automatically print out to the console, as opposed to so you don't have to go to the CloudFormation service console to see how your deployments have actually what the outcome of your deployments actually were. So super useful and a great time saver. And we'll be continuing to do more work in this area as time goes on. The customers are also telling us they want to make it easier for them to follow development and deployment best practices for serverless. And to this end, we announced the integration of the serverless lens and made it part of the well-architected framework and the tooling that is available to you in the console now. So serverless application model provides a lot of the best practices and helps you identify how you might be able to remediate some issues, and providing you with resources to help you get a feel for and understand operationally how your serverless applications are aligning to the pillars of the well-architected framework. And this is a really useful tool, not just from a pre-production phase, but also from that can be applied during development. So you make sure that you're on the right path rather than having to spend lots of time remediating potential issues once you've done all the work up front. And it's a super useful learning tool to understand around how all of the services integrate to help you build serverless applications in the best way possible. And that's all we have time for today, folks. I just wanted to say thank you. I hope this has been an informative presentation. We, as an organization, are continuing to work backwards from your needs and looking at new ways we can help you build more loosely coupled system and allow you to innovate faster, so you can start to focus on what's really important, and that is like delivering better products to your and services to your customers. Please look out for future events and features throughout the rest of this year and moving forward, and please provide us with all of the feedback around the features that we have released and things that you think are missing. It's a really important time to be able to get your input on how to deliver and iterate on the things that you need. So please reach out and let us know. And with that, I want to say thank you very much. If you have a moment or two, we would definitely appreciate some feedback on this presentation. We've created a very short survey. It shouldn't take more than 1 or 2 minutes to fill out. But your feedback is important to us, and hopefully help us improve our the way that we deliver and the content that we create in events like this. So thank you very much.